Okay, so we're going to take a look at creating a simple crowd simulation of a set of agents walking across a geometry. Um, so I am going to create a geometry node, and inside of here I'm going to create an agent, and that agent is going to be an FBX file that I have created already. It is just basically a walking animation. Leg rig walk accept. And it makes it super tiny. I made it to not necessarily to scale, but close to scale. By default, it has convert units on. We can turn convert units off. So he's something like 1, 2, 3, 4, 5 meters. He's huge, but he's also not tiny the way it was before. Okay, so we have this guy here, and if we push play and push real time, we can see what the animation is. It's just a walk going across the scene. Okay, so now we need to prepare this file to work. So agent prep, and inside of here, this character's only lower limbs that we're going to be working with. So we can add 2 of them. So we have the left and the right. And then I have access to my skeleton right here. So upper leg for me is going to be hip. Then I have the knee. Then I have the ankle. And I have the toe. And then over here, I can set up the right hand side. So I have right hip, right knee, right ankle, and right toe. There we go. So if we set this up on a crossover or a planted frame right here, we can look in wireframe mode. These are what's going to be detected for collision with the ground. Right now the ankle is up high. So we want to take the ankle and bring it down to the ground. So I want to make sure that it is right underneath the ankle and that it is on the ground. So just tweaking it. There we go. So we're right there on the grid. And for the toe, I'm going to offset it down a little bit too. There you go, because that's the bottom of the geometry itself. When we look at it with the wireframe turned off, actually that's a bit low. So, and maybe a little bit too far out, so wrong direction. There you go. So the ankle and the toe. If I want, I can actually push the ankle to the back here. But that is good for what we're going to do. Now I want to figure out the other foot when it plants here. So that's the right hand side. What I can do is copy this and paste it, but it's going to be some of the values may be offset. So here we can see that this is going to be let's put this negative really quick. Negative. And then this is positive. So it's the inverse of what we had on the other one. And then we have 0.1 and 0.11. And you can see that it's the inverse. So we need negative value and a negative value. There we go. Now that's planted and it is set up the way we need it to be. Okay, and now let's create an agent properties node. So agent clip properties. And in here, we're going to take a look at, so the clip preview, we're going to do take one. And let's add a clip here. It gives us the name. I'm going to do take one. And actually, with the name over here, the preview name, we don't need that. Let's remove that, and we're fine there now. And it is over here. And we can see what we got with the cycle here now. So if we push play here, you can see it keeps on looping around, and we don't want that to happen. We want it to keep on walking forward here. So let's do the loop range. We know it's 1 to 24 that the loop is happening. That is good. Then let's go back to the agent here, and I'm going to scroll all the way down, and I'm going to tell it to convert to in-place animation, and I'm going to tell it to move based off of the pelvis. So that's the center joint here. So that way it knows where it's moving forward. And now you can see once I switch that setting, it's going to walk on forever, and it looks like a really good cycle there. So in the agent properties here, I made this cycle by hand animating it, so it's not motion capture or anything, so it lines up really well. If you are using a motion capture clip, you can also do blend while looping, and what that will do for you is will blend with the first 3 and the last 3 frames between the 2 animations. So if you see any popping, you can turn that on and adjust how much blending you want between the frames. So let's see. So for me, that's where it's blending. But if I turn the blending off, because I know that I animated it, you don't see that sliding. So in my case, it's actually better to keep the blending off. But sometimes there's a huge pop when you're using mocap information. And in those cases, you want to make sure that you are blending the frames or kind of matching up the animation and cleaning it up beforehand. Okay, so now let's go over here. And what we're going to create is an out node. Or sorry, not an out node, a null node. And we're going to name it out. Out underscore properties. And now that we have that, we can move on to creating the crowd source. So we'll do that here. Create a crowd source. And we can adjust the crowd source. This is, well, let's look at the agent really quick because we did change this convert to in-place animation. So what you'll notice here is that it actually is walking in single place. These property animation here is just showing you how it's going to work, and you can tweak the settings to make it look right. The crowd source here is basically creating your agents that you are going to be replicating. So You can set up an area if you wanted to. Let's say 50 by 50. You have all of these agents, and you can create more if you wanted to. Let's say we had that many. This input here, if you had like a geometry set up where you wanted them to start off at, you can connect it there. So it doesn't have to be grid, but it could be a modeled surface, so that way it's not a perfect box, but then you can adjust the properties here. And then it's going to be using that as the input for there. Also, you can paint a density attribute, and right now I don't have anything, but if you did, you can paint the density in there, and then it will put your agents in those specific areas only. If I look at this now, we can see that it's all walking in a single place. That's the way it should be, but they're all walking synchronized together. The crowdsource also lets us randomize some values. So let's go in and randomize clip time. Random clip up to 1 second. This is 24 frames, so it's 1 second. So that way we can have a whole bunch of different walking animations there that are a little bit different. You can also randomize scale if you wanted to. So that way there's some small ones and some big ones. That looks pretty good. Okay. So now, let's go ahead and create a null node here. And that's going to be our out agent. Then let's create a DOP network, and this is where we're going to set up the whole simulation. So I'm going to double click in here. Inside of here we need a crowd. Oops, sorry about that. You're going to create a crowd solver. Connect that in here. And in here we're going to need to connect, for our purposes, 3 nodes. So we need a crowd object. Then we need a crowd source. And then we need a, oops, I didn't mean to do that. Crowd state. So this is our walk state. If you had different animations, you can bring in a merge node here and then connect the different animations that you have. In this case, I don't. I just have the one walk. The crowd source. Let's go here. We have object, geo, agent, accept. Then the crowd object here. Let's connect the properties, out properties. Let's look at frame 1. Everything is all broken so far. So let's look at the crowd state here. And single clip. Let's look at this really quick. Okay, so with the crowd state, we need the clip name, take 01. And then I think that is it from here. So we can go, let's copy this back to the crowd source. Go to setup. And initial state is walk state. Let's see if that fixes things here. So now we have it visualized. We can see that the rig isn't broken. Let's see when it plays. That is looking okay. The problem is that with the crowdsource here, we have velocity. We don't want to use the velocity. That's moving it forward. That's why it's all slipping. So let's play this now. Now it's all staying still, and we got the DOP network visualized. That is good. Let's jump into the DOP network. Let's look into here. And right now, we're going to change it from in place to locomotive, which is what will trigger it to be able to walk forward. There we go. So we got a crowd of our characters, and you can see that they're kind of choosing to walk in different directions and stuff. That is good. So we have a crowd working. Now let's create, let me save this just so that I don't lose it. Actually, I'll save it later. Let's not waste time with that. Let's go to our object level and create a ground. So this is our agent. And then we can create a geometry node. It's going to be based off of a grid. This is ground. Let's make this maybe 200 by 200. And then we'll move it forward into the Z. So that way it has some range to walk on. Let's add a mountain node. And the amplitude, let's crank this up. Let's try like 50. Let's bring the resolution up on this. And then on the mountain node, let's adjust the element size. There we go. So we have some sort of terrain that they're going to be walking across. Now that I have that, let's go to the... Actually, and over here, we'll create a null node. That it's going to be out underscore ground. And we can visualize that. Okay, let's go back into our agents, our DOP network. And in our crowd solver, we can go to terrain. And we can do enable terrain projection. Go to the SOP path and select the out node here inside of the ground. Accept. So you can see that it already adjusted for that. And I'm going to enable foot locking so that way the feet will lock onto the angle of the floor. So if we turn that off, actually it looks like it's still working okay, but I'm going to enable foot locking just in case. Okay, now if we can see here, we should have the crowd kind of coming over the edge here. If I play it through, you can see that the agents are walking across the surface here. I like that a lot. And then over here, because there's no ground, I think it will just like eventually... Nope, it just stayed there. That's good. So let's go make some adjustments here. I want to take this and adjust the size so that I have a little bit wider range. And maybe a little bit wider here. And then I can add maybe more agents. Okay, so let's look at how that is looking. We can see we got all of those agents coming across the ground. That is amazing to see. Okay, so all that's working. Now, let's say we take this and let's cluster it a little bit. Not wider, I want to bring it in closer. And then let's shift it over this way. So it's kind of starting off on the side here. And inside of the ground, let's create a curve. And this curve, make it a NURBS curve. And I'm going to snap it onto, not the grid, onto primitive. There we go. And then let's select this tool. Okay, gonna finish it there. So I have a curve that is going along the surface of the geometry relatively closely. And this is gonna be our null, it's gonna be an out path. Okay, so let's go over here, back into the agents, back into the DOP network. And what I want to do is add a pop steer path. Connect that in here. Instead of a pop force, we want crowd steer force. And then over here, we want the path that we just created. So let's go out here and see what, if anything, happens. I'm not sure if all of them will follow because we have such a big crowd right now, but they're generally going to try to follow the path. Some of them took a shortcut because they got closer to this end over here, but it's just tweaking the curve and making sure that it is where you want it to be. But you can see generally they are going along the path. So if we wanted to, we can go in here. Actually, let's take this grid and let's move it more off to the side over here. Let's go to frame 1 so we can see, and then let's make it a little bit narrower. Okay, let's try playing this now. Just gonna match it a little bit closer. There you go. So we have a big crowd of characters marching out. So let's try 350, just so we have a few more frames. And once it gets past the crowd, it's just gonna kind of wander. It won't necessarily know what to do after that point. So that's a super basic, simple crowd simulation, getting it to work with a path and a terrain, getting our characters moving around and everything. So I hope you guys found this useful. We will see you guys in the next video. Bye.